Okay, so picture this. You're in a massive crowd, maybe at a concert or a game. You pull out your phone to watch something, and suddenly it feels like you're back on dial-up internet. Why does that happen? Well, today we're going to dive into the science behind that awful lag and explore a brilliantly simple new idea that could make buffering a thing of the past. We've all been there, right? You're at some huge event, you just got the perfect video, and you want to share it. But instead of uploading, you're just staring at this, the infamous spinning wheel of death. It's become this universal symbol for frustration, and it's basically a giant warning sign that our mobile networks are just buckling under all the pressure we're putting on them. So just how big is this strain, really? Before we can even get to the cool solution, we have to wrap our heads around the sheer scale of the problem. And let me tell you, the numbers are kind of mind-blowing. All right, get ready for a number that's almost impossible to imagine. In late 2024, the world was consuming over 157 exabytes of mobile data every single month. What's an exabyte? Oh, just a billion gigabytes. That is an absolutely colossal amount of information just flying through the air around us all the time. And here's the real kicker. Look at what's eating up all that data. A staggering 75%, 3/4 of all mobile traffic is just for video. Streaming, sharing, watching, all of it is putting this incredible, focused load on the cell towers that we all have to share. So how in the world do we fix this massive data traffic jam? Well, researchers have come up with a really clever new approach, and we can break it all down with a simple analogy. Let's call it the backpack and the neighbor. Okay, so the first part of the solution is a concept called caching. Imagine a library. Instead of every single person traveling all the way to the library to get the most popular books, what if the library just preloaded those popular books into everybody's backpack? Well, in the digital world, this means your phone would proactively store popular stuff, like a viral video, so you don't even have to ask a faraway server for it. That's your backpack. Now, the second part of the puzzle is device-to-device communication, or D2D. Let's go back to our analogy. If the book you want isn't in your backpack, what's your next move? Well, instead of that long hike to the library, you could just ask the person sitting next to you if they have a copy. D2D tech lets our phones do exactly that. Share files directly with other phones that are nearby, completely bypassing that overloaded cell tower. That's your neighbor. So this combo completely changes the flow of data. The old way, well, it just creates a giant bottleneck, right? Every single phone trying to talk to that one central tower, the library. But the new way is decentralized and so much smarter. First, your phone just checks its own storage, the backpack. If the file isn't there, it looks for a neighbor. And only as a last resort does it bother the main tower. Okay, so what would this actually look like in practice? It's a really simple two-step process that your phone would just follow automatically every time you wanted to watch, say, that concert video. It works just like this. Step 1 is self-offloading. The second you hit play, your phone checks its own local cache. Does it already have that video stored in its backpack? If it does, boom, it plays instantly. If not, no big deal. It just moves to step 2, D2D offloading. Your phone sends out a little local ping, basically asking if any nearby phones have the file. If a neighbor has it, that file gets zapped directly to you. This all sounds fantastic in theory, but the big question is, does it actually work? Well, researchers didn't just guess. They put this whole auxiliary caching strategy to the ultimate test in a really powerful simulation. So to see how this idea would hold up under pressure, scientists actually built a digital model of a huge city. They filled this virtual world with tons of simulated mobile users who were all requesting, caching, and sharing popular files with each other, basically mimicking the absolute chaos of a real-world crowded network. And the results? They were pretty incredible. This chart here shows the average time it took for a user to get their file. If you rely only on the cell tower, the base station, that's the tallest bar, the slowest by far. Using just the neighbor system, D2D, was better. But the new backpack and neighbor strategy, look at that. It's dramatically faster than both. We're talking about a huge drop in that frustrating waiting time. And hey, you don't have to take my word for it. The researchers' own conclusion says it all. In their words, this strategy effectively reduces the mean delay. In our words, it just means it works. It really, really works to slash that buffering time. So we have a major problem, a really clever solution, and the data that proves it works. But what does all of this actually mean for you and how you use your phone every day?
Well, the payoff is a much better mobile future for all of us. I mean, imagine significantly faster downloads, way less of that annoying buffering, and having a reliable internet connection even when you're packed into a stadium with 50,000 other people. The whole network just becomes way more efficient, which is a better experience for everyone.
So I'll leave you with this thought. The next time you're at a live event and you're stuck staring at that spinning wheel, just imagine a different future. A future where that amazing high-def replay you're trying to watch isn't coming from some server hundreds of miles away, but is just streaming seamlessly from the phone of the person sitting right next to you. That's the power of this idea.